Hi guys, welcome to Calc with Cola. So today I want to talk about some tips and tricks for the AP Calculus exam. It applies to both AB and BC. I will do a separate one on BC only things. So this is just random tips and tricks that I always say in my class. So first tip is, let's make this a little bit thicker. Anytime they give you an initial condition, like something like this, and they want something else, so like f of c, and they give you the derivative, it's what I want equals what I'm given. I say this all the time in my class. Plus the integral between the two of them of the derivative. So that's a fancy way of saying the accumulation function. F of b equals f of a plus the integral from a to b of f. And just note, a is always going to be like whatever's here is going to be the lower bound here. And sometimes you're going to have to negate it and flip it. Tip number two. If you see particular solution, they want the particular solution. It means separate and integrate. So separate and integrate and get y alone. Big idea. Get y alone. Okay, step 3 or tip 3. I don't know why I keep saying step 3. If you see an x, the integral symbol, and a t, you're thinking second FTC. So this is what I mean. This is what I call it. So say they give you g of x is the integral from 5 to x of f of t dt. So that means we're going to derive everything. The derivative of g is g prime of x. And everywhere we see a t, we're going to replace it with an x times the derivative of x, which is just 1. I tell my kids, put this in a box because it's important on your page. And then usually, whatever graph they gave you is usually the graph of f, and you also know it's the graph of g prime now. Tip number 4. If they ask for relative max and min, that's when you make a number line this way, and you put your critical points on the number line, and you're plugging into the first derivative to see if it's plus, minus, plus, and whatnot. But if they ask you for the absolute max and min, or they say minimum value, maximum value on a closed interval, then that's an absolute max and min question, and you're going to want to do my t-chart, x, f of x, and what goes in the t-chart are your endpoints, EP for endpoints, and your critical points. Could be more than one, could be just one, whatever. All right, tip number 6. For rate in, rate out questions. Rate in and out questions. This is really important. If they want to know if the amount of sand, amount of people, amount of fish, is increasing or decreasing at a time. Let's say time equals 5. I'm just making it up. Then you're going to do rate in of 5 minus rate out of 5. You're going to use your calculator. And if it's greater than 0, then the amount is increasing. If it's less than 0, the amount is decreasing. But if they want to know if the rate of fish, rate of people, rate of whatever, is increasing or decreasing at time 5, then you need to do the derivative of rate in at 5 minus the derivative of rate out at 5. Same thing, if it's greater than 0, then the rate's increasing. If it's less than 0, the rate's decreasing. All right, next tip. Number 7. If they want the total amount in, rate out, meaning how many people entered the building, how many people entered the mall, entered the parking garage, blah, blah, blah. You're always going to do initial amount, which they will tell you if there is any, plus the integral of rate in minus rate out. This lower bound right here is whatever the question starts at, and then I like to go up to t and make my rate in and rate out functions of x. So like r of x minus L of x. I'm making up the functions. Next tip, number 8. If they want us to find area, do anything with area and volume. Whenever you're drawing your discs or line of rotation, like your lines to the line of rotation, if your line is vertical, to find the length of it, it's always top minus bottom. If it's horizontal, it's always right minus left. That's really important to remember. Next, they love a good cross-section question. So for cross-sections, just remember, all you're doing is to find the volume using cross-section, you're integrating the area of the shape. And what shapes do you need to know? You need to know a square is side squared. An isosceles right triangle is 1/2 base squared. A semicircle is pi r squared divided by 2. They love a good rectangle, which is just base times height, and they're going to relate the base and height to something. And I guess they could ask an equilateral triangle, which is rad 3 over 4 base squared. Got to memorize those. All right, tip 10. I'm going to make a statement. I make the statement in my class all the time. If they want to know if something, I'm going to capitalize the word something, is increasing or decreasing, look at the derivative of that something. I'm going to give you some examples. So look, say they want to know if, let's do a prettier color, this color. If position is increasing or decreasing, you're going to look at the derivative of position, which is velocity. If they want to know if velocity is increasing or decreasing, you're going to look at the derivative of velocity, which is acceleration. If they want to know if the derivative is increasing or decreasing, you're going to look at the derivative of the derivative, which is the second derivative. Okay? All right, next, tip 11. You're going to do a u sub for any integral. If it's not just x. This is what I mean. If you have sine x, you don't need to do a u sub. But if you have sine 2x, obviously you can do this in your head. Don't come at me if you want to. But if you love a good u sub, you could u sub this. U subs are going to be everywhere. All right, 12. You better memorize that 1 over x integrates to ln of x. That is going to be on there. And that e to the x integrates to itself. And I tell my kids to memorize that rad x derives to 1 over 2 rad x. It's just going to save yourself some time for evaluating if you need to. Number 13, if you have to use L'Hopital's rule, which you're going to have to somewhere on the test, remember his rule. It says you plug in the number, you get 0 over 0 or infinity over infinity. You take the derivative of the top and the bottom and try again. So these are equivalent to one another. F prime of x over g prime of x. And we're responsible for 0 over 0 and infinity over infinity. And you need to show the limit of the numerator equals 0 or infinity and the limit of the denominator to get full credit. I know it's annoying, but it is what it is. Just suck it up, buttercup. All right, 14. If you're doing implicit differentiation with respect to x, then you derive x like normal. So derive x like normal. But when you derive y, you derive y like normal, but you better throw on a dy dx. Tack on a dy dx. And last but not least, when you're doing related rates, whatever variables you see, you better have a dt when you're deriving it. Meaning if you see a v, there better be a dv dt. If there's an h in your volume formula or whatever you're deriving, there better be a dh dt, and so forth.